What are the major differences between infrared and near-infrared spectroscopy? Hi, I am Dave van Staveren. In this video, I will briefly explain the differences between mid-infrared spectroscopy, IR spectroscopy for short, and near-infrared spectroscopy, otherwise known as NIR spectroscopy. Both IR and NIR are vibrational spectroscopies, meaning that parts of the molecules will vibrate when absorbing light at specific wavelengths. As the names imply, IR and NIR spectroscopy use different spectral ranges of light. This wavelength variation results in three key differences: the required sample size, penetration of the light into the sample, and the resulting spectral information. Let's look at the first difference, the sample size. Vibrations in the infrared region are classified as fundamental vibrations. As such, they have a higher probability of occurrence than overtones and combination bands, vibrations happening in the near-infrared region. Therefore, infrared light is absorbed more strongly than NIR light. Because of this, small sample quantities should be used with IR spectroscopy. Sample preparation is often required as well. For example, needing to press a potassium bromide tablet or prepare liquid dilutions. Conversely, the absorption of near-infrared light is much weaker and samples can be measured as is, without any sample preparation needed. In addition, longer path lengths can be used when measuring liquid samples with NIR spectroscopy. This is especially useful for online measurements in industrial process environment. Now for the second difference between IR and NIR spectroscopy, the sample penetration by the light. Often, it is only possible to collect information about the surface of a sample when using IR spectroscopy. NIR light, on the other hand, is of higher energy and therefore penetrates deeper into the sample. This makes NIR spectroscopy the ideal choice for studying heterogeneous samples, as information can be collected from a larger sample area in this situation. Finally, the third major difference, the spectral information. IR spectra are suitable for identifying functional groups within a sample, as well-defined, sharp bands are observed for various functional groups. In contrast, bands in NIR spectra are much broader. This makes identification of functional groups more difficult. The benefit of these broader overtone and combination bands is that you can also quantify chemical and physical parameters of the sample. For this quantification, mathematical models called prediction models are required. To summarize, IR spectroscopy is well suited for the identification of substances. However, sample preparation is usually needed, which can be time-consuming. Also, the analysis of heterogeneous solid samples is a challenge for IR spectroscopy. On the contrary, NIR spectroscopy can be used for the identification of molecules and quantification of chemical and physical parameters, without needing any sample preparation. Because of the increased penetration depth of the NIR light, the analysis of heterogeneous solid samples is also possible. When dealing with liquid samples, longer path lengths can be used for NIR spectroscopy compared to IR spectroscopy. A strong argument for using NIR spectroscopy for online measurements in industrial process environments. For more information, visit our website or contact your local Metrum specialist. Thanks for watching.